Alright, if you guys could please turn to 4.6, Use Congruent Triangles. Okay. Explain how you can use the given information to prove that the triangles are congruent. Angle 1 is congruent to angle 2, and AB is congruent to DE. We need to use this information to prove that DC is congruent to AC. Okay, if you can show that triangle ABC is congruent to triangle DEC, you will know that DC is congruent to AC. Basically, if these two triangles are congruent, then the corresponding sides have to be congruent also. First, copy the diagram and mark the given information. We already did that. Then add the information that you can deduce. In this case, angle ABC is congruent to angle DEC. In this case, these two angles are supplementary to congruent angles. And if you guys remember, if you have two angles that are supplementary to either the same angle or to congruent angles, then those angles are congruent. So angle ABC is congruent to angle DEC. Also, ACB is congruent to angle DCE because they're vertical angles. Okay, so here's the given information. We're given that this angle is congruent to this angle and this side is congruent to this side. I'll mark that over here also. We also determined, as you can see up here, that this angle is congruent to this angle and this angle is congruent to this angle. So let's just take a look at the information inside these two triangles. It looks to me that we have two angles and a non-included side. So two angle pairs and a non-included side are congruent. So by the Aas Congruence Theorem, the two triangles are congruent because the corresponding parts of congruent triangles are congruent. DC is congruent to AC. Okay, now, in this case, we did a paragraph proof, so you can just write it out like this. In a two-column proof, rather than writing because corresponding parts of congruent triangles are congruent, you could just write this. CPCTC. Okay, this stands for corresponding parts of congruent triangles are congruent. So in a two-column proof, if you were to rewrite this in a statements and reasons fashion, you would have your given, you would have a bunch of other steps, and then eventually you would get to, I don't know, maybe step 4 or 5 or whatever. You would say these two triangles are congruent. By Aas congruence. After you prove these triangles are congruent, then you can say DC is congruent to AC. Why? CPCTC. You can just use this as a reason. Okay? So here's an example. Alright, let's go on to page 2. Example 2. Use the following method to find the distance between two docked boats from point A to point B. Place a marker at D. So AB is perpendicular to BD. Okay, so AB perpendicular to DB. Okay, find C, the midpoint of BD. Now, remember, because these are perpendicular, we know this is a right angle. Because C is the midpoint, you know that this is congruent to this. Locate E so that BD is perpendicular to ED, and AC and E are collinear. Okay, so they already marked this one. These are collinear, meaning they make a straight line. Explain how this plan allows you to find the distance. Okay, because AB is perpendicular to BD and BD is perpendicular to DE, angle B and angle D are congruent right angles because all right angles are congruent. Because C is the midpoint of BD, BC is congruent to DC. Whoops. The vertical angles ACB, that's this angle, and this one, angle ECD, are congruent. So, triangle CBA is congruent to triangle CDE by the ASA congruence postulate. Now notice, even though these are right angles or right triangles, we're not using hypotenuse leg because we don't know anything about the hypotenuses of the triangles. We have two angles and a side in between the two angles, so we're using ASA. Then, because corresponding parts of congruent triangles are congruent, CPCTC, that's this reason, BA equals DE. So you can find the distance AB between the boats by measuring DE. Okay? Alright, I'll let you guys do the checkpoint. Let's go on to page 3. Use the given information to write a plan for the proof. Given angle 1 is congruent to angle 2, that's labeled for us. Angle 3 is congruent to angle 4, that's also labeled. We need to prove that triangle ABD is congruent to triangle ACD. So these are the two triangles we're looking at. In triangle ABD and triangle ACD, you know angle 1 is congruent to angle 2. And AD is congruent to AD. This is congruent to itself, but that's reflexive property. If you can show that BD is congruent to CD, you can use the SAS congruence postulate. Okay, so we know this angle is congruent to this angle, that's given, and AD is congruent to itself by reflexive property. All we need is this side and this side. So how do we do that? To prove that BD is congruent to CD, you can first prove that triangle BED is congruent to triangle CED. If I can prove these two triangles are congruent, then of course this side and this side have to be congruent because corresponding parts of congruent triangles are congruent. You're given that angle 1 is congruent to angle 2 and angle 3 is congruent to angle 4. ED is congruent to itself, reflexive property, and angle BDE is congruent to angle CDE. So basically, this angle has to be congruent to this angle because if these two angles are congruent and these angles are supplementary to congruent angles, the congruent supplements theorem says that these angles also have to be congruent. You can use the Aas Congruence Theorem to prove that triangle BED is congruent to triangle CED. Okay, so the plan for the proof, use the Aas Congruence Theorem to prove that triangle BED is congruent to triangle CED. Then state that BD is congruent to CD, okay, by CPCTC. Use the SAS Congruence Postulate to prove that these two triangles are congruent. And we're good. Alright, I'll let you guys do this checkpoint. Let's go on to page 4. Write a proof to verify that the construction for copying an obtuse angle is valid. Okay, add segment BC and EF to the diagram. Let's see here. I'm going to try to draw a straight line. No, that didn't work. Close enough. Close enough. Alright, so in the construction, AB, DE, AC, and DF are determined by the same compass setting, as are BC and EF. So you can assume the following statements. AB is congruent to DE. AC is congruent to DF. BC is congruent to EF. We want to prove that angle D is congruent to angle A. Okay, our plan for the proof, we're going to show that CAB is congruent to triangle FDE. So you conclude that the corresponding parts, angle D and angle A, are congruent. Okay, statements and reasons. We already know that AB is congruent to DE, AC is congruent to DF, BC is congruent to EF. That's given. So we have three sides. All three of these are sides. So triangle CAB is congruent to triangle FDE. SSS congruence. Therefore, angle D is congruent to angle A. Corresponding parts of congruent triangles are congruent. CPCTC. Alright, and that's all for today.